Okay, so here it is all soldered up. I added some header pins there just to get power in, power out connections. We'll flip over and get a shot of the benchtop multimeter, get some power hooked up to this, and do some adjusting. Okay, getting the test probes hooked up here. And we'll get some power applied. Okay. All right. So right now I've got 0 volts going into it, and I'm going to slowly crank this up. You'll see that voltage increase. I'm going to set this for about 12 volts, which is what you would typically get off a car or a wallboard or something of that nature. Like I said, this can handle anywhere from 1.5 on, well, actually 3 volts on the input, because it's going to drop 1.5 across the entire board. So if you want a 1.5 volt out, you're going to need at least 3 volts in. But it can handle 3 volts up to 30 volts on the input. And that's about as high as we're going to go. I'm sitting at, yeah, 11.3. Okay, so now I have to find my screwdriver. I've been misplacing that thing all day long. Oh. I have no idea where it ran off to. Anyway, I'm gonna bump this up just a little bit more. Okay, so we're showing 11.8 on the multimeter, and then over here on the power supply, 13.5 on the input. You got the input there on the alligator clips, and multimeter obviously going to the output there. So I'm going to grab the screwdriver, and then we'll adjust this down to something usable. Okay, so now we'll adjust this down to something usable. Like, let's say you have an Arduino or a Raspberry Pi that runs on 5 volts. You can adjust it down to that. Let's say you want to create a battery eliminator circuit for something that takes a 9 volt battery. You can do that as well. So what I'm doing here is just adjusting that screw on the potentiometer and slowly bringing that voltage down. So we can set this to whatever we want. Like I said, if we wanted to do 9 volts, we could do that. Or down to 5, or anywhere up to 30, anywhere in between. So this project, it was a success, but I'm not running any major load on this. And those traces that we talked about in the beginning, I did the calculations on those. Those are only going to be able to handle 1 amp max. And like I said, I designed this for 3 amps tops. So I'm going to have to send those boards off to be redone with wider tracks. But then we'll probably get it up on a website and either sell the entire board, sell it as a kit, so you can solder the pieces together if you want, various number of things. But anyway, the importance of this is, you know, there's got to be logical steps into your design. So we need to have a power supply first. before we can do anything else. So from here, we're probably going to go into microcontrollers. Basically, you give it some software programming, tell it what to do. It can look at a various number of pins, either digital inputs and outputs, analog inputs and outputs. For those of you that don't know, digital is simply high or low, 0 or 1. In this case, it would be 0 volts or 5 volts. Analog would be anywhere in between 2.2, 6.5, you know, whatever the case may be. But think of that in terms of getting information back from sensors, controlling motors, controlling servos, any vast number of things there. So there's a video that I've been contemplating putting up, basically direction of the channel. One of the major projects that I want to undertake as kind of an open source. We'll get into that probably on the next video or the video after that, because I think, considering how long this video has run already, the solder paste stencil soldering of the other board I will save for another video. So anyway, thanks for watching. You guys have a good one. Bye.